Think AI is just for spam filters and cat videos. Guess again, it just joined the air defense squad. Picture a Mach 10 missile crashing the border like it forgot to RSVP. AI tracks it in real time, plays 4D chess with the trajectory, and fries it with a laser sharp enough to tidy your eyebrows on the way out. Your security now rides on a neural network binge-trained on rocket telemetry and radar static. It doesn't blink, nap, or ask for bathroom breaks, just vaporizes threats like a Roomba with a physics PhD and zero chill, when the sky starts thinking for itself. On a humid June night above the Black Sea, a hypersonic glide vehicle tears across the exosphere at more than Mach 10. Before radar operators can shout a warning, an autonomous lattice of satellites, high-altitude drones, and shore-based sensors has already fused their data in the cloud, predicted the missile's exact route, and handed firing solutions to a laser battery on the coast. The beam fires, the warhead disintegrates mid-air. The entire sequence, detect, decide, destroy, takes less than 8 seconds, and no human presses a button. That vignette is not ripped from cinematic fantasy. It is a near-term operational concept sketched by engineers on 3 continents who are racing to embed artificial intelligence decision loops into every layer of missile defense. AI has stopped being the optional turbocharger bolted onto aging systems. It is fast becoming the central nervous system of 21st century deterrence. How AI rewrites the intercept equation. Classic missile defense architectures were reactive by design. Surveillance radars detected a threat, operators confirmed the track, commanders picked an interceptor, and only then did a battery fire. That timeline, often measured in minutes, cannot survive the era of hypersonic glide vehicles and drone swarms. Modern AI platforms use deep learning ensembles to absorb fire hose streams from satellites, over-the-horizon radars, and passive RF antennas, producing a fused battlespace picture every few milliseconds. In effect, the algorithm rewinds the engagement. It projects where the missile will be and decides what must be launched now so that metal or photons meet threat in the future. This predictive logic lies at the core of Israel's Iron Dome fire control software, which routinely ignores rockets judged to land harmlessly and commits interceptors only where lives are at stake. Global programs racing toward autonomy. The United States has placed its $175 billion Golden Dome shield at the center of its 2020s defense agenda. Reuters reporting shows the architecture will string hundreds of satellites with sophisticated sensors and interceptors into an AI-driven mesh able to shoot during the adversary's boost phase, long before traditional systems could react. In Ukraine, combat reality has forced innovation faster still. The Sky Sentinel automated turret has already downed at least 6 Iranian-built Shahed drones at a cost of about $150,000 per unit, pennies next to the $4 million price tag of a single Patriot interceptor. Ukrainian operators say the system independently scans the airspace, identifies threats, locks targets, and determines firing points, while a human simply concurs or vetoes the shot. Israel pairs its proven Iron Dome with Iron Beam, a 100-kilowatt laser expected to enter service by late 2025. At roughly $3 per shot, AI-directed photons promise game-changing economics against cheap rockets and micro-drones that would otherwise bankrupt a defender firing multi-million-dollar missiles. Europe is knitting together 20-plus nations in the European Sky Shield Initiative, layering Iris-T, Patriot, and Arrow 3 batteries into a continent-wide grid steered by AI command and control. The Bundestag alone has authorized 4 billion euros for Arrow 3 procurement and aims for an initial shield by 2025. India, meanwhile, field-tested its indigenous Akash-tier network during Operation Sindoor this spring and claims it intercepted every drone and missile launched across the border. DRDO engineers emphasize the system's ability to consolidate multiple radars into one automated decision loop, pushing India closer to self-reliant, low-latency air defense. The technology stack, sensors, algorithms, effectors. AI-driven missile defense is not a single gadget, it is an ecosystem. At the sensing layer, agile GAN-based radars such as Hensoldt's TRML-4D can track 1,500 targets simultaneously, feeding torrents of raw range Doppler data into neural networks. Overhead, small satellite constellations provide global, persistent infrared coverage, catching dim missile plumes seconds after launch, an essential prerequisite for Golden Dome's plan to kill in the boost phase. In the compute layer, militaries are rolling out ChatGPT-style assistants to help analysts interrogate those data lakes. The US Army's Ask Sage pilot, for instance, instance, piggybacks on retrieval-augmented generation to draft threat assessments and code snippets, freeing soldiers to focus on judgment instead of clerical work. Finally, at the effector layer, both kinetic interceptors and directed energy weapons now accept machine-generated fire solutions directly. The only physical limit is whether commanders allow an algorithm to pull the trigger, or merely recommend it. Costs, ethics, and adversarial algorithms. Advocates often trumpet Iron Beam's $3 cost per shot, but the sticker hides a sobering balance sheet. Golden Dome's projected outlay rivals America's Apollo program, and Arrow 3's German buy alone tops 4 billion euros. Nations are gambling colossal sums that AI will outpace threats long enough to justify the bill. Yet money is not the only wager. AI systems inherit biases from their training data and can be spoofed by adversarial inputs. A crafty enemy might feed phantom tracks into a sensor network, luring interceptors to exhaust themselves on non-existent targets while real missiles slip through. Cyber warfare squads are therefore training generative adversarial networks whose sole purpose is to attack friendly algorithms. Better to find the cracks in peacetime than under fire. The thornier debate is moral, with hypersonic flight times measured in minutes. Keeping a human in the loop could nullify defense altogether. Israel's Iron Beam and Ukraine's Sky Sentinel already operate on human on the loop. They act, people supervise. Should a laser misclassify a civilian airliner, who bears the blame? The coder, the commander, or the machine? Geneva Convention lawyers and ethicists are scrambling for answers as fast as engineers rewrite the kill chain. A year of breakneck headlines. The news cycle underscores how quickly practice follows theory. In May, Elbit Systems told investors Iron Beam would be operational by year-end, calling it an operational breakthrough, and citing a record $23 billion backlog driven by laser demand. At June's Paris Air Show, Anduril and Rheinmetall unveiled a joint drone line, Barracuda and Fury, explicitly designed to slot into European AI command nets. US senators flew in to bless the deal, signaling that Silicon Valley-style software firms are now pillars of transatlantic security. Meanwhile, Business Insider confirmed Sky Sentinel's first 6 combat kills, proving that autonomous gun turrets can hold their own on peer-to-peer battlefields. And in South Asia, DRDO hailed Akashtir's zero-leak performance during Pakistan's heaviest drone raid in years, nudging New Delhi toward full-spectrum AI-enabled air dominance. When every horizon is digitized. Project 5 years ahead. Over Washington, Patriot batteries engage hypersonic threats on machine queue, while overhead satellites relay trajectory refinements every 2 seconds. In Tel Aviv, Iron Beam nodes protect residential blocks, their optics slewing autonomously from rocket salvos to quadcopter swarms like a pianist shifting chords. On Europe's eastern frontier, SE Stitch's German TRML-4D radars, Polish Patriot launchers, and Israeli Arrow interceptors into a single AI decision loop that cares little about national borders and everything about milliseconds. In New Delhi, Akashtir trucks roll off highways, plug into India's integrated air command network, and begin engaging targets without ever exposing a crew. Kyiv's skyline bristles with Sky Sentinel turrets, each linked to low-cost compact lasers by fiber because bullets alone cannot keep up with the swarm. What unites these scenarios is not geography or politics, but code. Neural nets that never sleep, never panic, and, for better or worse, never forget. And there you have it, the rise of AI-powered warfare, where missiles think, drones swarm, and your next line of defense might just be smarter than your average honor student. If that blew your mind, and not your eyebrows, go ahead and smash that like button, hit subscribe, and ring the bell so you don't miss the next deep dive into the wild, weird, and occasionally terrifying world of future tech.